Hello everyone. Today, inshallah, as I was talking with you, we will cover the limits. As you can see, spring is here with no dust and everything. So you have flowers and birds and everything. Today, I will continue with the limit as I was telling you. Okay. I will start with this slide, but to keep things as short as possible, as I was telling you before we start. Okay, let me talk about the lateral limits first. Then I will talk about the limits in multivariable functions step by step. As I was telling you, the idea of the limit is to speculate or to link. When the input is changing, x tends to a certain value, what's going to happen with f of x? If I'm talking about lateral limits, so for example, that's the x-axis, and I have x node right here, and link it to it, this is the value of the function, of all of my function. If you are in lateral limits, you will approach x node either from the left or from the right. Based on this fact, the value of the function by itself, if this is your function, as long as the function or the input is approaching x node from the left, you will find the values of y is moving on the curve in order to reach the value of L or the value of the limit from the left. And if x is approaching x node from the right, same way like you will find your curve is approaching certain value. The advantage of studying the limits in one dimension, you are talking about just only one curve, which is the input, the x-axis. So you are approaching from the left and from the right, just only one way. And so the relation is really very simple, and as you can see, the limit will exist once the limit from the left is equal to the limit from the right, as you can see. So once more, D is said to be bounded if there exists R greater than 0, which means it is the distance that you are approaching x node from both sides. D belongs to the open ball, which is that I've tried to point out for you. And let I be an open interval in R, and x node belongs to this interval. There are only two ways in which x approximate x node, coming from the right or coming from the left. And if they reach certain value, then your limit exists, which is, you are familiar with this within the calculus of functions in one variable. Okay. Okay, example, really very simple, like this one. Miss Fatin, I want to evaluate the limit of this function near x equal to 1. All I have to do is just to check limit of x tends to 1 from the left or less than 1. So I will give it a point 1 negative. In this case, I will use the case where x is less than 1. So the function is 2 of an x plus 1. So start solving this limit. So the value is equal to 3. I will do exactly the same from the other side. The function is defined, which is x squared. So in this case, it's going to be limit x tends to 1 positive. So x is greater than 1, which means just a little bit greater than 1. So I will use this branch. Are you with me, Faisal? Okay. This is for x squared. Once you substitute, it's equal. As you can see, the limit from the left is different than the limit from the right. And in this case, there is no limit. So the limit of x tends to 1 for the function f of x simply doesn't exist. So, for this function, if instead of having positive 1, if this guy is negative 1, what's gonna be? If you are taking the limit from 1 less than 1, I will be dealing with this branch. Once more, let's try to substitute. So it's gonna be 2x minus 1. The result will be, and the limit from the left is equal to the limit from the right, then the limit existence equal to 1. Are you with me? Okay, this is an advantage, a huge advantage, actually, for the lateral limits, because you have just only one direction. You are studying from this direction. So one small limit of x1 minus is going to be 2, which will lead to 3. From the other side, it's going to be 1. They don't equal to each other, so the limit doesn't exist in this case. If they equal to each other, then the limit exists. Once we go, okay, so lateral limits, as I told you, the input variable approach certain value through one pass only, and this is really very important to keep in mind. From the left or from the right, that's a simple simplification as we did previously. This is for the input trying to approach x naught from the left or from the right, and due to this, you will find that the function is approaching certain value also from above and from beneath, and once the function, the x approaching x naught, the value of the function will approach L, and that's what was explained actually in the previous. The main problem now, if I'm moving into the n dimension or the multivariable functions, okay, Farid, just be careful from the tripod, okay? Just to check.
check it.
check ايه؟
الكاميرا مظبوطة؟
مظبوطة وشغالة.
بص
حضرتك عايز البورد ده؟
ايه؟
حضرتك عايز البورد ده في
لا. هنا ده بس واضحة قدامكم عشان
كله باين زي الفل.
اوكي بصوا يا شباب. This is x and y. That's the plan. I'm trying to get near this value which is x node y node. بص يا فندم, there is plenty of curves as I explained previously. In order to approach this value, any point from the space, I'm sorry, from the plan, من أي نقطة من البلان ده, لو هي عايزة to approach this point, you have infinite number of curves. صح? I will have to study the most of them. Actually, I should study all of them, which seems like mission impossible because it's an infinite number of curves. Okay? You can't cover all of them. So, the main idea, we will study 3 methods. We will study 3 methods in order to handle this issue. By the ideas here, this is actually happening and it's so difficult while you are in the plan. Can you imagine if I'm in 3 dimension, x, y, and z, that's the point in the space. The number of infinite curves that pass through this point, it's something really very, very enormous, okay? So, what I want to say is, we have 3 methods that we will try. The directed limits method, the iterated limit method, and Cauchy's method. The first 2 methods are just only for speculating the value of the limit. You will never be sure about the value of the limit using the iterated or the directed method, even though before we start them. But they are a step in order to introduce a value for you to check by the general limit or by Cauchy, as you will see. Okay, that's the bottom line. In this part, you will have tons of problems covering these ideas. Also going through using parametric representation, using polar representation, using Cartesian. All of these tools, we already have them. We covered all of this in the previous parts. So I will show you how to manipulate and how to master the relations, okay, related to inequalities. So let's start step by step. The first, as I told you, this is the limit of xy. See, that's in the plan. If xy trying to approach AB, the value of the function will equal to L. Okay, at the point, this is the definition exactly as was explained, so I'm not gonna lose time, more time in all of this. I've already sent you the PDF to be with you previously. Okay, so all of this just trying to expand the idea. Okay, for this limit, which is f of xy, x squared y squared, limit xy tends to the origin, I want to see how it's going to be when the function is going to reach, or what's going to be the result. So if I'm using the directed methods, I can do the following. Before even we saw it on the screen. بص فريد, I will try to choose certain curves. Okay? So I will try to approach this, the value of xy, to approach the origin. I will try to use the x-axis. Through the x-axis, what's the equation of the x-axis? Y equal to 0. So actually, I will solve limit of x and y approaching the origin for the function which is x squared plus y squared, while you know that y is equal to 0, which will lead to limit of x and y approaching the origin. I will substitute by this value. So I will have just only x squared. Faisal, substitute, so the result will be 0. So now I'm approaching the origin for this curve, but through the x-axis. Okay, why not to use the y-axis? Okay, I will do it. I will try to see if I'm using the y-axis as a proposed curve. Okay, so once more, for the y-axis, x is gonna equal to 0. So it's gonna be the limit of x and y approaching the origin for an x squared plus y squared, while x is equal to 0. So it's the same way like. So it's gonna be, Ms. Fatin, the limit of x and y approaching the origin and will lead to y squared, and once you substitute it's equals 0, which is a good indication. I've tried the x-axis, the result of the limit is equal to 0. I've tried the y-axis, the result is equal to 0. So Ziad will tell me, why not to try y equal to x? Okay, let's do it. Okay, that's another curve. Y is equal to x. So in this case, you will find that I have limit x and y approaching the origin. And while x is equal, y is equal to x. I will use this curve. In order to do this, I will make a substitution using this relation in my limit. So Faisal, I will have the limit of x and y approaching 0 and 0 using this relation, which leads to 2 over an x squared, which also will be. So also, Mr. Farid will tell me, why not to use y equal x squared? Why not to use y equal x squared? I will have a similar limit. A similar result. So y is equal to x squared. It's going to be exactly the same. It's the limit of x and y going to x node, y node, while y is equal to x squared. So it's an x squared plus a square. I will make the substitution. Also putting x equal to 0, the result is 0. From all of this, now I have 100%, or nearly, that's 90%, okay? That the limit when xy tends to 0 for this function, the value will be 0, okay? Still, there will be the hunch, what if there is another curve? Once you make the substitution, it's not gonna equal to 0, okay? Are you with me? So, as I told you, this is why it is not just a proof, but this is how the directed method. So at the time being, I'm suspecting that the value of the limit of this function f of xy, when xy approach 0, is gonna equal to 0. This is my point of view, okay? So once more, if I'm trying, no matter how you approach y equal to x, y equal to 0, or y sine x, the result will be equal to 0, so the limit exists and it's equal to 0. Okay, that's another example. Okay, Ms. Fatin, I have function f of xy, which is equal to xy divided by x squared plus y squared. And it is approaching the origin. I will try to do also exactly the same. Let's use any curves. Let's say y equal to x. If I'm using this substitution, I will do the substitution first, ya Faisal, before applying the limit. So all I have to do is to replace y by x is gonna be x squared, and this is also gonna be x squared. So you will have x squared divided by x squared plus x squared. So the result will be half. So the limit when xy tends to the origin is equal to half. That's the first limit, keep it with you. Okay, let's try another curve. That's another curve, which y equal to negative x. All I have to do is to make the substitution. So I will go for y, replacing y by negative x, replacing y by negative x, but unfortunately, I'm not gonna have the same value I had negative of. Once the value of the limit is not equal with any curves, it means the limit doesn't exist. Okay, that's very good. Okay, limit along the curve. This is also an explanation of what's happening, so I will skip this slide. Once more, that's another problem. You want to investigate if the limit of this function exists using different curves. Look to the number of curves. I will use the first curve, the x-axis or the y-axis. So I'm using the x-axis, y equal to 0. So once you put y equal to 0 here and there, you will have 0 divided by whatever. The result will be 0. Okay, let's try the x-axis. The x-axis, y is equal to 0. So if you put y equal to 0, also you will have your denominator equal to 0, which means the limit is equal to, once you use y equal to 0, I'm sorry, the other, it will be the 0. If you try y equal to x diagonally, and they make the substitution, the result is half. That's enough just to have two curves with the limit doesn't equal to each other. So the limit doesn't exist. I'm not going to continue. Okay? So once more, the limit doesn't exist for this problem. Here the limits of two variables. Still, if you want to use parametric representation, now you know what is the parametric. What do we mean about parametric face-off? I will replace y by certain function in t. I will replace x in certain function in t. And instead of having xy approaching certain value, I will find the corresponding value for t. It's like a substitution, okay? And in this case, if I have a function in 2-dy, it will be changed into a function in 1 dimension. Because instead of having the limit of x and y, you will deal with the limit just only with t, okay? Also, it is applicable and it's exactly the same. That's the x and y. The result will be x as a function in t, y as a function in t. And the limit instead of f of xy, it will be, instead of xy tends to x node y node, I will be dealing with t tends to t node after this substitution. That's the in-depth, the relations related to this or how it is working. Those are the input x and y, both of them as functions in t, and for the output value, also it will be a function in x, which is function in t, a constant function in t. Okay? And this is how it's gonna be. Now for the directional limits, we already covered this issue by using the various relations of x equal to 0, y is equal to 0, y is equal to x, y is equal to mx, or y is equal to mx minus x node plus y node, which is the general relation for a straight line passing through certain point if you are approaching x node and y node. Okay? So it's a similar result. Of course, for this function, you have f of xy, which is negative xy divided by x squared by y squared. He is asking you to calculate the directional limits at the point 0, 0 along the x and y axes and along the direction lines x equal to y, x equal to negative y. So all of these lines, I want to check the directional limits. So the bottom idea, I will use the substitution first, then I will apply the limit after. So for the first one, this is along the x-axis. What's the equation of the x-axis? Y is equal to 0. So I will start first substituting by y equal to 0, then I will use the limit. So once more, it's going to be 0 times x divided by the denominator, the value is going to be 0 before even using the limit. So once x axis, the limit is equal to 0. If y axis, the limit is still equal to 0. طيب what if I'm using y equal to x? بص كده فيصل. If I'm using this guy, تقدر تمشي معايا فيصل؟ هيبقى limit xy tends to the origin. Start making your substitution. It's gonna be x, am I right? Times x divided by x squared plus x squared, which is gonna be x squared by 2 of an x squared, which the result is equal to half. So, okay, and a similar debate on minus half, when you still have a negative value. Similar debate can be done for the other relation when y equal to negative x. So when x is equal to y, as I told you, I make the substitutions equal to negative half. If I'm using, خلاص, at this point, I don't have to continue, okay? Because the limits, those guys are equal to each other, while on this curve, it doesn't equal to them. So the limit doesn't exist, okay? But even though, if you try to use x is equal to negative y, the value is half. So this guy is negative half, this guy is half. As you can see, zeros, so it gives different values using different curves. The limit doesn't exist simply, so it doesn't exist. Okay, I want you to remember, in the previous lecture we had some topological definitions, the lateral limits of functions in one variables, limits of multivariable functions, or the directional limits that we already dropped, okay? Till the time being. Now I will talk about the Cauchy definition of limits, which is the general way to be sure that the limit of this function reach certain value. Cauchy's limit is very important, and it is actually one of the general methods in order to evaluate a value of a limit. The idea is really very simple, which means for every epsilon greater than 0, there will be, or there exists, delta equal, greater than 0, such that the distance from xy approaching a and b is less than certain positive value, which means you can make an open ball around the input of this function, and will result to an open ball around the output of this function, which leads to that f of x minus L is less than epsilon, which means, let me put it this way, if I have 13 point, and that's when x and y trying to approach a and b, okay, this open ball will have r, radius, and the radius in this case must be greater than 0, and this radius, I will symbolize it by delta, which is greater than 0, some value greater than 0. How to measure the distance or the radius of this open ball? Simply by finding the norm of this epsilon, which is actually the norm of x and y minus a and b. And this is why you can see this guy, that's the norm that we are talking about. So actually this is the radius of this open ball, remark Mr. Farid, in the input. Of course we know a function, it links the input with the output. So due to this fact, you will find in the output, this is the value of the function f at a and b, and for the function f of x and y, we should find an open ball, in this case with a radius. If this epsilon, here it's epsilon, delta, then we could find an epsilon, open ball, in which the value of the function f of xy will approach f of a and b. And that's a proof of the limit. So, while xy are changing around an open ball with a radius delta, the same happens in the output for having an open ball which is having a radius which is epsilon, which is the difference between the function and the point. Okay? This is why we call it the delta epsilon proof or method in order to evaluate the limit or the general limit in general. That's the link. In order to make this happen in mathematics, we go through this. So we state that for every, epsilon greater than 0, there exists delta greater than 0, such that the norm of x and y minus a and b, is gonna be less than delta, and this will lead to the norm of f of x and y minus f at a and b is gonna be less than epsilon or for some epsilon. And through this, we will find a relation connecting delta with epsilon. That's the relation. which stresses that if delta greater than 0, epsilon will be greater than 0, or vice versa. That's the main idea of approving or proving using the definition, as you can see. So mainly that's the definition that we want to use. So once more, Farid, I want the function f of y to get close as you like to the number L, which means the norm less than delta, as I told you. Less than epsilon. Whenever the point xy get close enough to the point AB, so it is within the open ball with radius equal to delta, okay? That closeness is measured using the distance formula in R2. This is why I'm using the norm, okay, in the Euclidean space. Functions of several variables for f of x equal to L, that's sufficient and necessary to have for every epsilon greater than 0, there exists a delta greater than 0, such that the open ball of x at center A is less than delta, and belongs, when x of course belongs to the domain, which will lead to f of x minus L less than epsilon. Okay, in this PDF, I've also translated the mathematical expression for you into an English in order to make it easier for you. So let f belongs to the domain of R, and R be a function, a limit of D, and the L belongs to R. We say that the limit of f of x as x approaches A is L, written as limit x tends to A, f of x is equal to L. When if for every epsilon greater than 0, there exists delta greater than 0, such that these 2 points, whenever x minus A less than delta, we will have f of x minus L less than epsilon. That's the terminology of the definition of the general limit. Ms. Fatim, are you with me? Okay, once more, this is the distance in the input, and that's the distance in the output. In a similar manner, this is if I'm talking about lateral limits or limit in one variable. If I'm talking about limits in multivariable functions, it's going to be exactly the same. Because you are using, in general, the norm, which is the distance between the point xy and A and B. So it's going to be exactly the same. But instead of using the absolute in R, I'm using xy minus AB, which is the norm of the distance between these 2 points. And also that's the relative for the output. Once more, for every epsilon greater than 0, there exists a delta greater than 0, such that whenever xy minus AB is less than delta, you can find f of xy minus L is less than epsilon, exactly the same as we did previously. And that's the distance between xy and then AB, and that's the distance in the output between the value of the function and the value of the function at AB, which is the limit, okay? Also, it is explained, as I told you, this is for the lateral limits, and that's for the definition in 2 dimensions. That's xy, that's an AB, that's the delta, the open ball, and the result will be the open ball that you can find in the output as explained to you. Once more, useful, but before we go through, we go further using these definitions, I would like to add some tools with you, because we will deal with inequalities. You have a certain amount of inequalities with x and y, minus the A and B less than certain value, so I will need to know some knowledge about inequalities. Those relations are really very important, and they will actually ease your life a lot. I want you to know that the absolute of x is less than or equal x squared plus y squared. Because as you can see, when we are dealing with these steps, you will find at certain points, I will change the equality into inequality using these relations. So now I know that absolute of x is less than or equal the root of x squared plus y squared. Same way like absolute of y is less than or equal the root of x squared y squared. If I have just only x squared, I can freely replace it by less than or equal x squared plus y squared. And it makes sense. Okay? Also, y squared, for sure, it's gonna be less than or equal x squared plus y squared. Okay? If x is equal to 0, they will be equal to each other. If there is any value of x, then the left hand side will be greater, the right hand side will be greater than the left hand side. Same way like sine of x, absolute, the maximum faisal is gonna be 1. So it's less than or equal to 1. So if I phased sine x absolute, I can easily replace it by less than or equal 1. Are you with me? Also, for cosine x, same way like the sine absolute of x. For small values of x, it will be less than or equal absolute x, which means it will be less than or equal the root of x squared plus y squared. It's exactly the same. Are you with me? This is the manipulations that I'm telling you about. Okay, once more, I have absolute of x, which is equal to the root of x squared, which is less than or equal the root of x squared plus y squared. شباب غاية في الأهمية السلايد اللي في ايدك دلوقتي غاية في الأهمية، لأنك هتلاقي وأنا بشتغل بشيل ابسولوت اكس واحط روت اكس سكوير واي سكوير، بتشيل ده وتحط ده وتختصر مع بعض، هتعرف تجيب الريليشنز دي ازاي؟ معايا؟ فدي مهمة جدا. طيب تاني النورم اوف اكس واي هو عبارة عن السكوير روت بتاع اكس سكوير واي سكوير. تاني once more absolute of x is less than or equal to the norm. And absolute of y is less than or equal to the norm of x and y. هو مين النورم بتاع x and y ده زياد؟ السكوير روت بتاع x سكوير بلس y سكوير. اوكي؟ برضه مكتوبين قدامك هنا. خلي بالك ان a plus or minus b is less than or equal absolute a زائد absolute b. معايا فيصل؟ This is really major. اوكي؟ خلي بالك ان انا I can use polar coordinates. يعني in some kernels, in some cases, your function is going to be complicated. So one of the ways is to replace into polar coordinate pattern. Then how to change the polar coordinates? X squared plus y squared is going to be changed to r squared. Okay? So I'm using this relation. see, r equal to the root of x squared plus y squared. يعني ده معناه ان r is equal to the norm of y. I'm sorry. And r is equal to the norm of x and y. Are you with me? So r is equal to the norm. Also, this relation is really very important. And all I did is just to make simple substitution between these relations. That absolute of x is less than or equal r. And the absolute of r is less than or equal to r. Also, and finally, as xy approaches the origin, you will find that r approaches 0. From here, Faisal, if xy tends to the origin, x tends to 0, y tends to 0, so r will tend to 0. This slide is really very important. All of these tools will work together through the problems, as you will see in the coming slides. Once more, that's the Lisbon definition. It's exactly as I explained to you, but that's from the main slides. Here is explaining to you, بصي شوفي كده فتن, he's explaining to you. This is x node, y node. That's the open ball in the input, which will result an open ball in the output. This is f of x, y, and how it is approaching L. So here I will have delta, but here I will have epsilon, which is the difference between the value of f of x, y minus L. Okay? Okay, perfect. You want you to show that, or he is telling you that I want to find the limit of 2x cubed minus 3y cubed by x squared y squared equal to 0. I want to check this limit. Also, Faisal, the method of Cauchy doesn't find the value of the limit. No. It checks the correctness of the assumption. What I mean? For a function x cubed plus minus 3y cubed over x squared y squared, when xy tends to 0, I don't know what the value. Cauchy is not going to tell you what's the value. But it's a method to test a proposed value. What I'm trying to say, if I want to evaluate Farid, if I want to evaluate boss, if I want to evaluate the limit, I want to evaluate this limit. I'm not going to be able to evaluate the limit using Cauchy. Okay? But if I'm using directional method or iterated method, and it is supposed to be equal to 0, I can use this general method to be sure that the limit is equal to 0. Do you understand the measure? You are checking your head, but
Yes.
Yes.
for sure you understood.
Indeed.
Okay, very good. تعال نشوف how to prove it. طيب خليني انا اعملها لك الاول بعدين همشي للستارت لو انا عايز احلها. اول حركه عملت خلاص انا دلوقتي عارف الفاليوز صح؟ So all I have to do, I will say that for every epsilon greater than 0, we will have delta greater than 0. I will start طبعا delta is greater than 0 يعني ايه؟ يعني ايه delta is greater than 0؟ يعني معناها ان النورم بتاع الاثنين دول which is x minus 0 to the power of 2 x squared plus y squared under square root is less than epsilon, I'm sorry, is less than delta, and the delta by itself is greater than 0. That's the relation in the input. I will start from the output. So actually, Miss Fatin, I will start from here. The norm of 2x cubed minus 3y cubed divided by x squared plus y squared. I will start from this guy. Okay, I can say that this value can be written as 2 of an absolute of an x times x squared minus 3 of absolute of y, okay, times y squared divided by x squared plus y squared. These results are equal to each other if this is the absolute value. Okay, also it's gonna be less than or equal. Remark, the denominator will stay the same, which is x squared plus y squared. While the denominator, I will change x squared by x squared plus y squared. Okay, I will have 2 of an x. Since I have an absolute, so negative 3 also will be greater than that value, with plus 3 of a y times x squared plus y squared. In this case, of course, I still have the absolute values about x and y. In this case, I can take x squared, y squared as a common from the denominator and delete it with the denominator. Now I ended up having 2 absolute of x plus 3 absolute